Good. Quick intro. So my name is Kersten. I'm part of the technical marketing engineering group working on our Clara platforms for healthcare. And I've spent probably close to the last 2 years focused almost exclusively on NVIDIA FLARE, working closely with Holger and the engineering teams to make sure this platform is meeting the needs of our end users and helping people understand how to move kind of from development and simulation into real world deployments. So I'm going to zoom out a little bit. Jay Sharif did a great job of kind of introducing the FL landscape and where it can be useful. Holger's presentation really highlighted the development workflow, especially as it relates to MONAI FL and that integration. And I'm going to look more at the platform level at FLARE. The nice thing about the MONAI FL integration is that you have an easy way to deploy MONAI applications, but that's within the context of FLARE as a whole. So you have these tools for security, privacy, deployment. So I'll cover a little bit of that. Just to set the context, what I'm going to look at here is kind of carrying on from what Holger showed in the development environment. We'll look at the tools for deployment. I'll cover a little bit based on questions, what the operations look like and the structure of a FLARE application and how it's deployed. And then I'll also touch on some of the tools we have for ensuring security and where kind of the security within FLARE ends and some of the considerations you have to think about for site security and system security in the real world. So just to set the stage for the high-level architecture, this is stepping back to look at more the capabilities of FLARE and what a real-world deployment looks like. On the top right, this is kind of our hub and spoke cartoon where you have a FLARE central server that's performing aggregation of a model that's trained on a set of distributed clients. And on the left, you have an admin client that's used to manage the federation as a whole. So this would be controlling the clients and server, checking status, looking at logs, deploying applications. Within the FLARE system architecture, on the client and server, we do have this capability for submitting different jobs and scheduling on a set of resources. Holger mentioned a deploy map. You can use that to execute jobs on subsets of clients or to set up multiple jobs that are scheduled depending on when resources are available. And in the bottom left, for long-running jobs or jobs that would be sensitive to failure, we do have a hot, cold, high availability architecture where you can implement multiple servers and orchestrate failover to backup servers so you don't lose your progress as you run through this real-world training. The nice thing about FLARE is that at its core, it's a Python library, it's open source, and everything is spec-based so that it's customizable and pluggable pretty much from top to bottom, all the way from the low-level APIs that handle identity and communication up to the higher-level applications. Some of the tools for provisioning, Holger showed the FL simulator. Once we start moving away from local simulation, we have some tools that allow you to kind of step into a real-world deployment. The first is a POC mode where you're establishing discrete identities and packages for clients and servers, operating in separate workspaces where you can use the admin client to orchestrate the federated learning experiment as you would in the real world. We have a feature that allows you to deploy with Docker Compose so that you have a secure deployment on discrete server and client. And then we get to provisioning for the real world. We have kind of our standard provisioning interface, which gives you configuration files and a CLI to orchestrate provisioning. And we have a new dashboard UI that lets you establish a central web interface for a project and allows clients to register their systems for participation in the federation. Just a quick look at the tools that we provide that allow you to interact with the platform. Holger showed the simulator. This is all built into the main NVFlare CLI. There's the POC mode that allows you to generate discrete packages, to look at a distributed deployment. There are authorization policy preview features to look at what policies are allowed on clients. And then we have this production provisioning where we have the provisioner, the dashboard, And there's also a tool to check the packages that you generate when provisioning to make sure that network connectivity is there, dependencies, all of the things that you need to run and connect a client to the server. And then coming in a future release, part of the provisioning will be generating cloud deployment scripts. One of our colleagues, Umair from AWS, we've done quite a bit of work with to do this on AWS. And some of that will be integrated into the platform so that you can generate some of the assets you need for deployment on the fly. So looking at the high-level architecture in provisioning, I want to highlight a few of these pieces and show how they fit together. Some of these round blobs are kind of the different roles in federated learning with FLARE. And then we have some of the different tools or participants in the federation, and then we look at the communication and how we establish identities among these. So it really all starts with a project admin. This is the person who's leading the study, and this is the role for provisioning the study up front that can be done either with the provisioning tool or the FLARE dashboard. And when you provision and establish the identities of the participants, what you get out of that is what we call a startup kit. And these startup kits contain configurations for the server, for the FLARE clients, the certificates that are used to establish identities and secure communication between the server and clients. So the dashboard, you can allow your clients to download these startup kits and connect. If you're using the standard provisioner, then the project admin would be responsible for distributing these startup kits. And once everybody has these, then you can connect the entire federated learning system, at which point you have these org admins and user identities. We provide tools that allow you to run a console to interact with your clients, for example, or as a project admin to interact with all clients and deploy applications. So once the connectivity between the client and server is established, then everything happens through an external admin tool. You could run this, for example, on your workstation and interact with a distributed FLARE deployment using that admin tool. Just to look at the details of a deployment, this is our standard provisioning config. And this uses what we call builder modules to generate these startup kits. On the right, you see a text file. This is where you identify the participants. So in this example, we're looking at high availability where you have an overseer that orchestrates HA. You have servers and set the ports that you're using for communication. Default for federated learning is 8002, and for these admin clients is 8003. You can customize that to your needs. And then the set of clients are defined here. And then this isn't the full configuration, but after defining the participants, you define the set of builder modules that are used to generate the startup kits. And so this can be modules to generate Docker scripts to run in a container, templates to build out the workspace, certificates, signatures, all of that is built in and runs through this provisioning system. I can probably skip this, and I do want to highlight the FLARE dashboard. So this is new in FLARE version 2.2. This allows the project admin to run a web server that handles all of the provisioning. This allows you to define the project as a whole and the details there, any requirements or a Docker image that would be used by the participants. This is how you would manage dependencies. You can define that upfront as part of the project. And then once you have the entire project configured, you can open this web interface up to clients and organizations where they can create a login, define their organization config, the roles of the clients, and even the resources that are available on the client systems. Once these clients are approved by the project admin, downloads are available for all the participants to download the startup kits, which contain all the scripts and certificates that they need to establish their identity. So that's kind of a high-level overview of provisioning and the tools that we provide. From there, I'm going to go into what the FLARE application structure looks like. Holger covered this in the context of the MONAI FL integration. I'm going to step back and just look at one of our simple hello world examples to illustrate what the application looks like, its configuration, and where this custom code lives. And this will help address some of the questions about deploying custom code to clients. To revisit this controller worker workflow, these configuration files define this workflow, the tasks that are assigned to the clients by the server, and the code on the client side that is used to execute those tasks. Looking at the server config, and Holger showed this for the MONAI controller and the scatter and gather workflow. This is where you define the set of tasks that are assigned to the client systems. And then on the client side, you define the paths to the client executors that implement these tasks that are assigned by the server. So in this example, we have a train task, a submit model task, and a validate task. And that's what's implemented in the custom code here that's bundled with the application. When you define an executor, you define a path. In this case, it's using the built-in learner executor. And then the components that are driven by that executor are in this custom code directory. So you have the PT learner that's implemented here. We're using the analytics sender for TensorBoard streaming. So that's the basic structure, and that's where you would identify custom code that would be executed by a client. We do have policies for clients that allow you to turn on or off the ability to execute custom code. So for example, if you didn't want to allow the project admin to push code to the clients when deploying an application, you could turn off this bring your own code feature, in which case you would have to pre-install that code on the client system for them to be able to execute it or reference it in the client config. This is where you would be able to push code to a client manually and allow a client to validate it before the project admin was allowed to execute the code. And this is just a look at what you can include in the custom code. This could really be anything. So like showing the statistics workflow, you could do some data pre-processing or data validation as part of this workflow. Whatever you implement in this custom code, you would just design in your controller workflow and client config tasks to execute that custom code. Once you have that code deployed, this is showing kind of from the admin client side what this looks like. And this is just kind of a cartoon with the server and two clients connected. And you can interact with the server and clients using this admin client console. And this is the tool that the project admin can use on their local workstation to push code to the clients and then start training using that custom code. There's a link here to the user guide that highlights these admin commands. Another way to orchestrate this is using the Python API for this admin tool. So this uses the same identity of the admin package that was generated during provisioning and gives you access to an admin API that lets you do things like upload the application, set a run number, deploy an app, and execute that app. Just a note that this admin API is really just a wrapper for the admin CLI that I showed on the previous screen. We're working to make this a more Pythonic experience so that you could orchestrate an entire study through like a Jupyter notebook, for example. So I'll stop here to see if there are any questions. I do want to keep moving so we have time to get to Umair's portion on AWS.
Yeah, no questions so far, so go ahead and keep going.
Okay, cool. Looking a little bit at security, just at a high level, you have to think about the distinction of the security aspects that Flare can handle and the external security aspects. So Flare implements identity security. This is done through provisioning and generating certificates to identify the server and clients. Communication security goes along with this. It's all mutually authenticated TLS using gRPC and TCP for the admin communication. And then the objects shared during training are serialized and deserialized between the communicating parties. We also have data privacy, which Holger discussed. These are applied in filters as part of that controller workflow to let you mask data to ensure that you're doing privacy preservation. This would include homomorphic encryption, differential privacy, those types of features. We also have auditing on the server and clients. This audits all the events that happen as part of the training so that as the owner of a client system, you can go back and see exactly what's happening through the execution. But outside the scope of FLARE, you have to think about physical security of the systems themselves, firewall policies, and then local data management policies, especially important in the case of healthcare, where you have PHI. Excuse me. In FLARE 2.2, we use what's called federated authorization. This allows individual clients to define their own policies, for example, restricting bring your own code, restricting what the different admin clients can do, and defining different roles to give different levels of access. Excuse me. What this looks like is just a local configuration that each client can set per client. Any questions about the security?
No questions so far.
Okay. With that, I am going to hand off to Umair. This just highlights some of the resources we put together with AWS. So there's a blog. We did a joint seminar highlighting these resources, and then a workshop that walks through provisioning.
Yeah. Cool. I will, let's hand it over to Umair, and that way we can, I know he's a little limited on time. So Umair, I see you there on camera. Feel free to introduce yourself and then go ahead and take it away on the second half of presentation for you guys. Thanks, Kris.
Absolutely. Give me 1 second. I'm just trying to see the screen share starts here.
Yeah.
Michael, looks like I don't have access to share my screen.
Let me see. Have you as co-host here. Let's see if I can. Is there a particular message it's saying when you try to share?
Oh, let me just check 1 second.
Yeah.
Okay, I see it now. Apologies for that.
Okay, yeah, no problem.
Looks like my computer was acting up here. There's like a Zoom problem. So, all right,
Okay.
and let me just bring up the presentation.
There we go.
You can see it?
Yeah.
Awesome. Alrighty. Apologies for that, guys. Hi, everyone. Umair, Khalid. I am a solutions architect as part of our AWS Healthcare and Life Sciences team. It's definitely great to be part of the event today. Thanks for the invite, Michael and Kris. So I'll be walking through the FLARE solution and how it can be deployed on AWS. And also we will discuss a MONAI example, part of the presentation today. And towards the end of the presentation, I have a demo from my colleague, Dr. Stephen Fu, and he's going to basically walk through a healthcare and life sciences use case end to end. But there are some links part of the presentation as well that I encourage you guys to take some screenshots or follow along part of the workshop. So I'm going to kind of dive in at a high level before we get into the nitty gritty. So Kris gave a pretty extensive overview of how, FLARE is architected from a solution standpoint. What are the different components of FLARE? But the next thing I wanted to do is kind of look at it more from how AWS will be involved and how you will be able to provision this. So in a federated learning workflow, you typically necessitate a server environment and a number of clients. So let's take a look at this diagram. You can see there are many building elements found in the client and the server context. So starting from the left, you can notice there's a FLARE clients. FLARE clients naturally receive instructions from the server. And as Kris mentioned, the clients will have a set of privacy preserving algorithms. on the client side, you will also have a local data set that is usually contained in an S3 bucket. And the client will also do where all the model training happens. So this is going to be pretty critical to leverage, optimize compute instances from EC2. So we have a number of NVIDIA GPU compute instances available on the AWS platform. And lastly here, the gRPC listeners, they are, of course, used to communicate with the server instances. All right, so now moving to the server side, on the right-hand side of the diagram, you see there is a FLARE server environment. The server manages the job orchestrations, like Kris mentioned. The server also manages the state of the FLARE clients. And when it comes to managing sensitive data, the server provides those privacy-preserving algorithms. And lastly, on the server side, the gRPC message broker for communicating with the client instances is also present. So these are just like the high-level building blocks of a federated learning environment, and you will naturally see on in an AWS platform. And of course, there will be a large number of clients that are connected to this server instance. So let me kind of dive into that angle here. So in terms of deploying FLARE on AWS on the cloud, there are a number of considerations that we recommend you take. It's going to be a distributed system, so it's important for you to actually architect this in a very robust way. And this diagram you see here is a typical example, right? So you have a central server environment, right? And you will have a number of these client environments as well, where they could be in different availability zones of AWS. And in a lot of scenarios, you will run into a non-cloud based or even another cloud hosted instance of clients as well. So we're going to consider all of that as we kind of move into our deployment model. So the first thing we very much recommend, and this is super important, is the infrastructure as code component. So the elasticity of the cloud is one of the primary benefits. As you guys know, with AWS, with the cloud, you can scale pretty extensively. And when it comes to FLARE, we advise you set up and deploy environments in infrastructure as code. And the reason we recommend you do that is because this will help you scale your clients in a repeatable and effective manner. So moving to the DevOps side of things, we have, of course, recommendations around you following DevOps pipelines, the best practices around DevOps, and making sure that a lot of the algorithms that are being developed are fully deployable in an automated manner and managed through a DevOps lifecycle. And additionally, we recommend that you have a realistic configuration of compute, networking, and storage. It's important for you to, as you scale your model development and add new clients to the federation, that your compute, storage, and networking can scale. The other consideration that we have, I kind of touched on this earlier, is the multi-cloud piece. So in the real world, of course, not all clients will be running on a single cloud platform. So you need to take into account the limitations of on-prem deployments and also potentially cross-cloud integrations. And then the last thing I will cover here is the debugging, metric collection, and logging component. You want to make sure that there is adequate debugging, logging, and metric collection happening at all levels, as this is going to be actually a pretty key tool for you to troubleshoot. Things get pretty complicated when you have a large set of clients communicating and things. You want to make sure that, especially from a server standpoint, there's a lot of logging happening within your AWS infrastructure, so you can see the network hops, things of that sort. And of course, NVIDIA FLARE also has its own set of logging capabilities that you'll be able to tap into. So let's kind of move into how and what are some of the components that you will use when it comes to a FLARE deployment on AWS. We of course kind of break the AWS cloud services. Some of the core services you see here is networking, compute, storage, identity management, and governance. These are all going to be very critical for you as you start your deployment process. So I'm going to start with networking first. So in the networking side of things, you have to consider hybrid environments, and things like AWS Transit Gateway comes into play. Also, this is going to be really important for you to have data and network isolation, right? So a lot of this data will be sensitive, and you don't want open access even within your cloud environment. So from an AWS standpoint, we have virtual private clouds as a key enabling component for that. When it comes to compute, we have a number of instance types that we, of course, recommend you use. Part of this I alluded to earlier is the NVIDIA GPU instances that are available on the EC2 platform. And on the server side, of course, you can use more general purpose instances, because that's, where the server is essentially there for you to manage the clients. The training is happening on the client side, and that's where your GPU instances come in. And one of the great things about using the cloud is we have these machine images available for you to leverage. So you can leverage the deep learning AMIs, Amazon Machine Images from NVIDIA, that have a lot of these libraries and tools built into it, and some pre-configuration already in place. And lastly, I will say on the computer side, there's auto scaling involved, so you can scale up your server environment or even your clients as the workload increases. So there's a lot of thresholds that you can set there. On the storage side, of course, you have Amazon S3. This is a great way for you to store all your sensitive data. NVIDIA FLARE also has part of the deployment, and we'll show you that part of our demo today, is provisioning and configuration capabilities. And that's where S3 can come in and allow you to store a lot of that information there. On the security and identity compliance side of things, for preserving the privacy of your data, also making sure the network traffic is very much in line with your security guidelines. AWS offers security groups. We also have a number of ways for you to block traffic on different ports and firewalls themselves. And then moving towards the governance and management side, I talked about the infrastructure as code piece. This is gonna be very critical for you to leverage. You shouldn't be deploying your FLARE environment without leveraging infrastructure as code. That's something that we highly recommend. And also, of course, part of your access controls and IAM, you can kind of log down really who has access to what EC2 instances and different AWS infrastructure. And then, of course, logging, something we touched on as well, where you want to make sure you're logging a lot of the network traffic and troubleshooting for troubleshooting purposes. All right, so kind of getting deep into the architecture now, right? So you've talked about a lot of high level concepts. Wanted to make a bit more of a real world use case in front of you, and this is also simplified a bit. There are some things that we have kind of simplified this diagram. There, if you were to document everything, it'll have a lot of other things that will be added onto this diagram, which are working in the background. But this is an illustrative hybrid federated learning environment using FLARE on AWS. So we see three institutions working together on model development. On the top, you see the on-premise client. The middle is the medical research facility and the cancer treatment center at the bottom. So the medical research facility, the medical research center, is actually hosting the Flare server within their AWS account, but in a separate VPC, as you can see. So VPCs are very important to kind of create that isolation, and that's the reason that the server is in a separate VPC. So on one key component I like to call it as well is the AWS Transit Gateway. So the AWS Transit Gateway connects your VPCs and on-prem networks through a central hub. The connection simplifies your network and puts an end-to-end peering relationship. So you're not going to have to manage a lot of these peer-to-peer connections. AWS Transit Gateway is a great way for you to simplify your network traffic and your architecture. It's essentially a highly scalable cloud router, and each new connection only has to be made once. So definitely we recommend leveraging the Transit Gateway, especially when it comes to hybrid environments, things which are not just running in AWS. And the last thing I'll say here is the Flare client instances on this diagram are using the NVIDIA GPU instances for efficient training. And a lot of the private data, and of course, we're coming at this from a medical healthcare use case. You see the private data will be housed inside of an S3 bucket, and this could be DICOM data in our case. All right, so that's the high-level overview, and we can, of course, we'll show you a bit more of a demo of how this actually comes about coming up here. But I wanted to touch next on the MONAI side of things as well. So we're going to show you a demo of course, how the Flare environment gets deployed and the configuration on the AWS side of things. But of course, you're interested in how MONAI can be leveraged. So part of the demo that I will be bringing up here, I'll be playing here shortly. We're gonna walk through a Flare on AWS workshop. Kris and AWS and NVIDIA essentially has collaborated on this workshop, and we encourage you actually to go through and actually follow the instructions as well, if you can. In this workshop, we actually go through a medical imaging use case using Flare and the MONAI bundle. And at a high level, what you will see is we're going to deploy Flare on AWS. We're going to connect the clients to the server. And once the clients are connected to the server, we're going to deploy the MONAI bundle. And this is going to be an example of a 3D spleen segmentation job. And lastly, what you're going to see in the demo here is a tensor board example where you can actually see the job status, metrics, and visualizations. The link is also present on the screen for this workshop, by the way. So if you are interested in following along the demo that I'll be playing here, please do that. We have shared a QR code, so you'll be able to access it through your phone.
I also put that link in both the Zoom chat and Discord chat as well.
Thanks, Michael. All right, so I'm gonna, sorry about that. Let me share my screen one more time.
We have already built and published. This content is available online. You will find the link later on in the final deck slide. Through this workshop, we will walk you through how to deploy the infrastructure, right? Like Umair mentioned, all the AWS resources, and enable you to run Flare on AWS. So there are a couple of deployment options. We will go through the simple one, which is the deploy everything in a single AWS account. You definitely have other options to deploy it. This deployment through CloudFormation template is an infrastructure as code approach. We'll create a network and the compute resource within the private subnet in different virtual private cloud to give you the network isolation and protection. Deployment will take 10 minutes. We will fast forward from here. Now you can see the stack already created. We will go to AWS Elastic Compute resource. You will see there are 3 different virtual machine has been created, 1 for master, 2 for clients. Let's connect the master first. We will use AWS System Manager, Session Manager to connect the instance within the private subnet. Once we connect you to the server virtual machine, we can start provisioning the startup keys for NVIDIA FLARE. The startup kit will be created on server and will be distributed to client. So we will running NV FLARE command line using a simple non-high availability mode. And then we will upload the startup kit to S3 bucket, and we can download from client machine to download those startup kit so we can provision server and client and make them connect to each other. The next step. As you can see, we use NV FLARE command line for this provision, but you do have other options to use the UI in the new version of NV FLARE, like Kris mentioned earlier. Now the startup kit have been provisioned, and we will go to the client machine and download those startup kit. So you can see we are connecting to client right now, also using AWS System Manager, Session Manager. We will use AWS command line to download the startup kit from S3 bucket. We upload it from the server instance. Now the client instance also have the startup kit. We will do this same provisioning for the second client as well. Both client server are running on GPU instance. We use a relatively small instance, which is AWS EC2 G4DN, a single GPU with a single GPU core. The server doesn't have to be a GPU instance in this case. Now we are downloading the startup kit on the second client instance. Once the startup kit available on server and clients, now we can start server and client and register client to server to make them connect to each other. We will also use the command line. Those steps available in the workshop content that published. As you can see, the server now started. Next, we will start client and register them to the server. We will change the U limit that setting to allow for this particular medical imaging AI ML workload. So now the first client already started and registered to the server. Next, we will start the second client using the same script. As you can see, the second client also has been started and registered. Now we can go to the server and check the status of two clients. We will use NVIDIA FLARE admin client to connect to the server and check status and also submit the job. Now we're connecting to the server using System Manager, Session Manager. This is a separate terminal, but for the same server instance. We will use NVIDIA FLARE admin client command line tool. Start the admin client. Log in using the email address. And we can run the command line to like check status of server. We can see how many clients has been registered. You can see there are 2 clients registered. Now it's confirmed the server and client are connecting to each other. We can prepare to submit a job. For this demo, we use MONAI FLARE integration. This is a new version of MONAI. It's publicly available on the on this GitHub, NV FLARE GitHub. So we will download the GitHub, all the content, the libraries, and dataset, and the step-by-step instruction available on the GitHub. We will follow the instruction. First, we need to download all the necessary library on the server side, and on the client instance, we will need to download the data and also install all the libraries. So now we download the MONAI bundle component on the server side. So server side configuration already set up. Now let's set up the client. First, let's go to the first client. We will use a script, a Python script, to download the data. This is for 3D spline segmentation. So the data set, the nifty image already prepackaged. We just need to run the command and download the image. We will do the same thing on the second client. So both clients will have the data locally to the executor. Once the data have been successfully downloaded to the client instance, we will see there's a data folder, right? All the image file locally on 2 clients. Next, we will need to install all the libraries, including FLARE, MONAI, and many others on both instances to let them be able to run the job. So once the data and the library have been installed on the client, we can start the admin client on the server instance and check status and submit the job. Now we log in the admin client on the server instance. We first check status to make sure the client still registered to the server. The 2 clients actively waiting for running job. And we list all the jobs. Right now, there's no job. And we will submit the job. The job configuration, the job already pre-configured, and we are using through the MONAI bundle we downloaded early on. You can see the job submitted. When we leave the job, you can see this job in submitted status. And later on, it transited to running status. Once the job started running, you will be able to see all these logs on the server side and also on the client side, right? On the client side, you can see the job starting running. First, you need to load the data set from the local storage to the executor running on the client, right? So this is the first client, second client. And once the job starting running, I fast forwarded a little bit. You can see it's starting training the job. We should be able to check the job status, all the metrics statistics using TensorBoard. So we will go to client 1 instance, and we connect client 1 instance through Session Manager. If we want to check the job status using TensorBoard, we want to check those data, the metric data will be emitted to this particular job. You can see the client running this job starting with the 1160 ID, and you can see the app side config has this Blink segmentation configuration, and there's a folder called evolve. That folder have all the metrics TensorBoard will look for to be able to visualize the job status and the metrics. Now we're running the TensorBoard server on the client side. It listens to 8080. Since the instance running within private subnet, we will use a Session Manager port forwarding feature to forward that port to a local port 1990 on your local instance. Now, on my laptop, I'm going to start a web page on my laptop to be able to see TensorBoard page running on the client instance. All those documentation available in that workshop, publicly available. So you can see this is the TensorBoard, the training status. You can visualize there. So that's a quick demo to show how you can deploy Flare on AWS, how to start the server client, and how to submit the job and check job status using TensorBoard. With that, we will close our today's presentation. Happy to take any questions. Thank you.
Alrighty, that was a demo from Stephen Fu from AWS. So Michael, I'm not sure if there are any other questions.
I didn't see any questions related to the presentation. So I think we should be good.
Awesome. Well, thanks everyone. This is the link to the workshop. We definitely encourage you to try it out. If you do have questions, feel free to reach out to me or to Dr. Stephen Fu or Kris. And yeah, we'll happy to provide any additional support. Thanks.